Hi all, welcome back to Node.js tutorial course and to my channel, obviously Tech Stack Learning. I hope you have all watched my previous session, which explains like different concepts of Node.js and its live coding examples. If not, I have given a link in the description box. Please do watch. So in this tutorial, I'm going to talk more about the Node.js streams. If you're working with a large data such as files, real-time video, or network connection, then streams are your best friend, as you all know. Instead of loading everything into memory, Node.js Streams allows you to process data piece by piece, making your application faster and more efficient. In this video, we will dive into what streams are, how they work, why they are essential for handling big data or real-time data flow. We will also cover different types of streams like readable, writable, duplex, and transform streams, and how and show you like some live coding examples. So whether you're building a real-time application or optimizing file handling, you are in the right place. So don't forget to hit subscribe button and give this video a thumbs up if you find it helpful. Let's get started. So, what is Node.js Stream, right? So, Node.js Streams are a powerful feature that allows you to work with large amount of data in a very efficient way. Okay, so rather than loading an entire file or data sent into your memory, streams allow you to process data in smaller chunks as it's being read or written, right? This is especially useful when dealing with large files or real-time data, as it keeps your application very lightweight and memory efficient. So there are four main types of streams, that is readable streams, writable streams, duplex streams, and transform streams. So what is this readable stream, right? Which are used to read data. Think of reading files from your file system or receiving data from a HTTP request. That is the how we call it. We think about the readable streams. So writable streams are used to write data. Like you might use this for saving data to a file or sending a response to a client. Then duplex streams. So it's a combination, as the name suggests, it's a combination of both, allowing for reading and writing data simultaneously, such as in a TCP socket connections, right? And finally, we have the transform streams, like which allows you to modify data as it's being passed through, like when compressing or encrypting the data. That is how we do it. Like it's called as a transform. C. Okay, so so you will see streams in action in many areas like file handling, web server responses, network communication. And one of the biggest advantages of using stream is that they handle back pressure. So what does it mean? This ensures that your application doesn't get overwhelmed with too much data at once by controlling the flow. Okay, so another great feature is piping, which allows you to connect multiple streams together. For example, you could read data from a file, then compress it, and then write it to the another file in a single continuous operation. So that is another key feature of this using of streams. So streams are incredibly efficient and versatile, and they are key to building the high performance scalable Node.js applications. Okay. Now let's see why to use streams, right? There are three key features why we have to use the stream. One is memory efficiency. Instead of, as I said, instead of loading the like traditional way of like entire file into memory, stream process in chunks. So making this them ideal for the large files and have a efficient memory handling. Okay, speed. Streams handle data in real times, like reducing the time spent for like waiting for the entire process to finish. Then flexibility, of course, streams are versatile and can handle files, network communications, HTTP requests, response, or any kind of large data set. Okay, now let's see what are the common use cases of this Node.js streams. Okay, first, it's mainly used for it is widely used across for this file handling, like reading, writing large files. That is the one of the common use cases which we have, like efficiently read file in a faster space, right? Streaming HTTP responses, like serve large files to users without loading the entire file into memory, which improves the performance. Okay, then we have real-time data processing, like stream data from external sources like APIs or database to process it as it's received. Useful for applications like chat system or the live fields. Then we have data transformation, like using this transform stream, we can compress, decompress the data on the fly. So modify the incoming or outgoing data in real time, such as converting CSV to JSON or encoding text files. That is another main common use cases where we'll use streams. Then network connections, like stream data over TCP connections, such as for real-time messaging apps, WebSockets, or video audio streaming, right? It's very helpful. Then data pipelining, pipe multiple streams together, like reading from a file, compressing it, and then writing to another file in a single flow. So it's like efficient transfer data, right? That is why it is very helpful, and that is one of the common use cases which we have. Real-time audio and video processing, like since the audios and videos could be very large, right? Stream live audio or video from the server to the clients, or vice versa, without buffering the entire media file in a memory. So basically, like it will be faster. Okay, log management, like stream logs in a real time for monitoring or analysis, like allowing scalable real time insights into server performance. Then last one is handling large data from databases, like stream database query results when dealing with the large data, like when we have millions of row at once, we cannot send it, right? That time the streaming will be very helpful. So using this Node.js stream, you can process data incrementally, making like your application faster, more efficient, and capable of handling large scale and real-time operations. So now I hope everybody has a clarity now on what is the stream, what are the different use cases, how does it work. Now let's dive into the live coding sessions on trying to see like what are the different types of streams and how to use it. Okay, so now let's see, start with creating a read stream. Okay, for that, I'm going to create one folder called streams, streams demo, and I'm just going to create a file called stream operations.js. Okay, I'm sorry, it has to be renamed. Okay, so obviously if we want to read anything now, first we have to create one file. So let me go ahead and create like example.txt file, and here I'm going to write hello world. Okay, so now let's go to this file. For using this string, the first is we will have to import the fs module. Okay, const fs equal to require of fs. Okay, so this is one of the important thing, you have to import the module first. Okay, now let's try to create a string. So we will have read string equal to fs dot create read stream. Then what is the file name? We have this example dot text, right? uh, and then what is that encoding we are going to give, like UTF-8 is the one which we are going to consider now. Okay, so this is going to read that particular file and have those assigned to this read stream. Now we have to listen whenever it's reading, we have to keep on listening to that data events, right? So what we will do, read stream dot, obviously you know that for any event listener we have to just click on, sorry, consider it on, right? So data, this is the event which will be considered whenever there is data incoming. we just capture, sorry, so I'll just as I said, it will be reading from chunk, correct? It will be chunking, it will be read at on the chunking format. It's not like at once it will be given, right? So what I'll do here is console dot log of, I will just print like new chunk. So as and when the data is there, it is going to print here. Okay, so whenever this is about listening to an event on the data. Now if you want to you have to end the stream, right? Once it is done, that is the best practice we have to always follow, correct? So here you will have to create an event called end stream, and then you have to just whenever there is the data is read completely, you can just uh, do whatever the operation you want to do. So for now I'm just going to um, uh, put a console log. Okay, so this is what I'm going to do. So let's try to run and see. Okay, streams. Okay, so node sorry, so you can see new chunk, hello world, file reading operation completed. So let me just add like few more lines, and we'll see how it is just um, taking it up. Okay, so I'll put tech stack learning. So let's try. Can see it has given this hello world text stack learning, and it takes in a chunking manner and just printed it. This is how it reads the string. So we saw how to read the stream, right? Now let's see how to write it to a stream. So we will create const write stream equal to fs dot uh, create write stream. Okay, then what we will do here again, I'll just give one output dot text as a file name. Okay, so here what we will do, once the stream is created, we have to just use the sorry write stream dot right, we have to write it, right? So you can just type hello world, um, welcome. Okay, this is how I'm writing. And if I have to write few more lines, like I'll just give like text stack learning. Okay, okay, and then once we have completed the thing, we have to end that. That is how we have to always end, so that it doesn't leak it. Okay, so output dot text, so instead of that I'm just going to remove the content of this example dot text. Well, we will just write it directly. Okay, okay, so let's run it. So I believe, let me just one sec, yeah. So it has been file, okay, it should be file reading completed, but nothing is here, right? It is not printing. So I will see that it should have been written whatever we have given, right? What if we try to run it again? So just replace it, right? It just takes whatever the content and it just gets replaced to um, the same content will be replaced on the file. This is about the writing this string. Okay, so now let's see piping the stream. Like one of the most powerful feature of the stream is piping. It allows you to pass data from one stream to another. Okay, so readable stream to writable stream. So let's give a try. Let's do that. Okay, what I'll do here is I'm just going to um create another code where I'll give new. Okay, then I'll give, this will be the input text. Okay, so this will be input text. Okay, now I'm going to create another one with write output text. We don't need this encoding here. Okay, then I'll put like write stream. Okay, so write stream. Yeah. So we have two streams created now, one for read stream, one for write stream. Okay, now how do we pipe this, right? So we want to write whatever is there in the input text. I know I want that to go to the output text, right? So what I'll do, I'll just put read stream new dot pipe of write stream new. So what happens here, whatever the content I have it in the input text, that gets uh, that gets sent to the output text. So what I'll do here now, I'll just create two file. Okay, so I'll just create input dot text and another one output dot text. Okay, so what I'll do from here, examples, I'll just copy this and paste it into the input text. Okay, now the output text is empty, correct? So let's close everything and let's see once we run how is it going to add it. Okay, okay, what is it okay, it should be right, right? So I'm sorry, it should be right. Create read stream. I have wrongly given it as a read stream. So you can see this has been completed, and if you see the output text, whatever was there in the input, it has been fed to the output. That is how the piping like works, like automatically reads from one stream to and writes to the another. So it handles the data transfer efficiently without manual intervention. Okay. Now let's see how to handle errors in streams, right? There will be situations that errors may occur for sure, right? So when that error happens, what we can do now, similar to this end, right? We can have like another event for error. So we will have error as another event. Okay, so whenever there is any error happening, we can catch like error, then we can print error dot message. Okay, so we have to pass this error here. This will be the thing which we are going to get it. Okay, so this is how, if any issue in the while reading or writing the stream, according for the each stream you can catch the error event and then you can display to the user, or we can handle it well. This is how we handle the error uh, in the streams. Okay. So now let's see what is how to transform and duplex the streams. Okay, transform stream can modify, like manipulate the data as it passes through the streams, right? So let's see how we can do that. Okay, so let me just try to import another module called zlib. Okay, so just name this way. Okay, so we have the readable stream. We already have the readable stream, and we have the writables. We have created a writable stream. So here what I'm going to do is I'm just copy pasting this to another set of streams. Okay, I don't want to use the same for now. What I'll do is, this is for transform. Okay, so that it is clear on the definition part. Okay, so I have the read stream which actually read from the input text. Okay, now I have a write stream. So what I'll do is I will have to output as a dot gz. Okay, so what I'll do here, I will just create gzip equal to zlib dot create uh, create gzip. Okay, okay, so what is that, this creates the gzip. What does it do? Creates a transform stream that compresses the data using the gzip. Okay, so this is, sorry, this is const. Okay, Here what we're trying to do is the readable stream is piped into the transform stream and then into the writable stream. That is how, and compressing the data in the real time. That is what we're trying to achieve here. Now we have created a transform stream that compresses the data using gzip. Now we have to pipe the stream with gzip transformation. So what we will do here, we will try to put read of dot pipe of what we will do gzip. Okay, this is what we are going to pipe, and we will do another pipe on right string. Okay, so this is like basically we are taking an input from the read stream. We are creating a write stream. We are trying to compress that first. Okay, and then we are going to pipe it to the write stream. So let's try to execute this. You can see this has been created in the JSON format. Like basically the output text, whatever is there, it has been given in the particular format. This is how the transform stream works. Okay, now let's see duplex streams that can read and write data simultaneously, like in network connections like TCP sockets, right? So what we will do here, let's try to do that. Const net equal to require of net. Okay, um, okay, so we imported the module net. So let's create a TCP server. Okay, so what we will do, net dot create server of, there obviously sockets. Okay, not docket, sorry, it's socket. Okay, then we have okay, here duplex streams can both read from and write to the socket. Okay, so what we will do, socket dot write of hello from server. Okay, um, okay, so we have written. Okay, now what I'll do, I'll just listen to this event called socket dot on data. Then we have data. Then we will just try to print whatever has been received. Okay, console.log of received from client. So here I'm going to print, okay, sorry, to string. Okay, so now we are listening to the socket. Also we are writing in the same server. Okay, so what I'll do here, we'll have to listen to the server now. Server dot listen, it will be, why is this, I think it came by mistake. This is basically some problem with my laptop, guys. Server equal to, okay, server equal to net dot create server. Now we will listen to the server dot listen, where we will listen to this port. Then we'll put like console.log. Okay, I'm just copy pasting it, listening to server. Okay, so let's remove this unwanted line. Okay, so let's try to run and see if we are encountering any issues. Okay, listening to the server. Okay. So this is how basically we create a net server, and if we go ahead and on this server, right, we write this hello from server, right? So whenever the data is received, it is going to print that data as is. Okay. So let's see now what are the best practices we have to consider while using Node.js Streams. Okay, the first one is use streams for large data. That is very much thing as I told in the previous slide. Avoid blocking operations, like stream work asynchronously. So avoid using blocking code within your stream event handler. Okay, pipe streams whenever required, like to connect to the streams between instead of manually reading data from one stream and doing it in another stream. Handle stream errors. That is another very key thing which we have to handle it. Manage back pressure. Like back pressure occurs when the writable stream can't handle data as fast as the readable. So use drain event and check the right to return the value to the control flow. Okay, then we can use limit stream size, like when accepting the input stream from users, you can provide the limit size to prevent the memory overload. Then use pipe, readable dot pipe with transform streams. Then optimize buffer sizes, like based on your use case, by default streams use a chunk size of 16 KB, which is suitable for most cases, but for large files, you may have to give the size accordingly. Stream cleanup, properly handle the end and close events to ensure resources like file handles are released. Okay, handle pausing and resuming. You can pause and resume the stream if you need to temporarily stop the flow of data, like readable.stream.pause or resume. We can do that. Use object mode for non-string binary data. So if you need to stream objects, not just buffers or strings, use object mode streams so that it allows you to work with objects rather than the binary data. Monitor performance, like regularly monitor the performance of your streams, especially in high throughput applications. So use tools like Node.js performance hooks and monitor event loops to identify bottlenecks. Okay, use end for writable streams, avoid memory leaks. That is very key thing. And use streams with async iterations. Okay, so by following all these best practices, you can efficiently manage large data sets, optimize memory usage, and avoid common pitfalls when working with the Node.js streams. Okay, that wraps up our deep dive into Node.js streams. We covered the core concepts from handling readable, writable stream to using duplex and transform streams for real-time data manipulation. You have seen how streams can optimize performance, save memory, and make your Node.js application more efficient, especially when working with the large data sets or real-time data. So whether you're streaming files, processing network requests, or handling data on the fly, mastering stream will take your Node.js skill to the next level. So in next session, I would be going with a different concepts of the Node.js. So if you found this video helpful, don't forget to like and subscribe for more tips and tutorials on Node.js and other tech topics. Also hit the notification bell so you don't miss any new content. Thanks for watching and see you in the next session.